Good afternoon. Wait, it's not afternoon. Yeah, it is. What time is it? Yeah, it's still almost morning. Good morning, gentlemen and ungentlemen. I thought I'd just record this because maybe someone would find it handy-dandified and useful and shit. So here is a Trio AT-200 antenna tuner. This is for matching an antenna to the frequency that you're trying to transmit on. Well, let's look inside of it. There are a couple of big variable capacitors that you can see here, right? And there's this big tapped inductor back here, and when you select a band on this front panel switch here, it selects a tap on that inductor, and then through adjusting the variable capacitors while you're transmitting, you can get rid of all of the reflected power on your antenna, so that you don't damage your radio or have like shitty output. Because the deal is like an antenna has to resonate on the frequency that you're trying to transmit on in order for it to transmit correctly. We generally do that by adjusting the length of the antenna or by using a tuner like this to match the impedance, right? So if the impedance is wrong, i.e. the antenna is the wrong length, and you send a wave of a particular frequency into it that's different than, well, an even fraction of that antenna length in general, part of the power that you're putting into the antenna bounces back into the radio, and that's what we call the standing wave, the reflected power. And that not only reduces your output power, but it can damage your radio. And so that's what these tuners are for, so I don't have to have 100 different antennas hanging off of my house of all different lengths, a specific length for every small range of frequencies that I want to transmit on. We can just use one antenna or a couple. It's got several different inputs for antennas. We can have just a couple of different antennas and tune them to the specific frequency that we want to transmit on using one of these boxes. The problem is this bad boy has been away for a long time. And I pulled it out of the old box and hooked it up to one of those T599s. I've got another one for parts now, by the way, too. I may have the market cornered on those old 599 Kenwood twins now. But so anyway, I pulled this out and finally dug my dummy load out. That's an antenna that doesn't radiate. It's just like a big resistor in a can, so that you can transmit into it while you're working on radios or tuning them without spamming the airwaves with your bullshit. You know what I'm saying? And they also don't have to be tuned. But I pulled the dummy load out, and I was trying to just use this as a forward power RF meter, just so I could see if I was getting output, because I wasn't getting anything on the meter built into the radio. And lo and behold, this meter isn't working. I couldn't get anything on this meter or the meter built into the 599 that I was trying to test, so I pulled out my 520 and tuned it up somewhere on 20 meters into a dummy load, and I was getting 100 watts out of the finals according to the meter built into the radio. I plugged it into the dummy load through this thing. Nothing on the meter. So either there's something very funny going on with my 520, or this meter for some reason isn't working anymore. So our project this morning is to just test this meter. There's not a whole lot to go wrong in these antenna tuners. There's nothing. There aren't any electrolytic capacitors. There's some resistors and it looks like a couple of diodes down in there. But those aren't going to go, and some ceramic capacitors, but there's nothing in here that should go bad just sitting. I don't know what's going on here. But if you're looking for one of these on the used market, these big air gap variable capacitors, all right? Depending on the spacing between the plates and the capacitors, that spacing between those plates is what determines how much power you can put through these air gap variable capacitors. If you're just tuning up an antenna to receive with, then you can use some tiny little close together like old capacitor out of an old TV set or something like that. But when you're transmitting through them, if the plates are too close together, the RF can arc between the plates and that'll damage the capacitor. So if you're buying an antenna tuner on the used market, that is probably what you want to look for, because those variable capacitors are what make these things as expensive as they are. Those are expensive parts to replace. If both of them are burned, you might as well just get a different tuner, in my opinion. But anyway, let's talk about these meters before we test this, because maybe some of you guys have some junk in the closet that you want to test the meters on. So here's a meter that I know works. At least it did when I took it out of the radio that it was in. This came out of that JR599, and I was getting deflection on the S meter in that thing. So the deflection on these meters is determined by the amount of current, i.e. the number of milliamps going through the meter. And some of them are different than others. I think that generally, at least with this older equipment, I think that full scale is usually 250 milliamps, but I may be full of shit on that. And there are two terminals in the back for putting the juice through the meter to make it deflect. And most of the time they're marked, the positive and negative one, but if they're not marked, it seems like the positive one is usually on the left. So if we're thinking about current flowing from positive to negative, which isn't actually how things work, but that's how we think about circuits when we design them. The current always flows left to right through the backs of these meters when you're looking at them, unless they're marked differently. At least that's how it seems. So the question is, though, then, if this is a device that measures current in its basic state without any support circuitry on it, how do we test it? Well, recall that voltage, V equals IR, amperage times resistance. So if we just put a resistor in series with the meter, it turns it into a voltage meter. So here's a 10K resistor. That's a pretty good value to use, I think. That ought to put us, put our voltages, in a decent space that the variable voltage power supply here can supply to test the meter deflection the whole way. So then we just have to, we'll come out of the power supply positive, go through the resistor. It doesn't matter which side you put the resistor on, as long as it's in series somewhere. We'll clip the resistor in here on the positive side, and we'll hook that onto the positive terminal of the meter here, and then we'll hook the negative side of the power supply onto the negative side of the meter and make sure that the voltage is turned all the way down, the current's turned up just a little bit. Flip it on and turn up the voltage on the variable voltage power supply very gently, and you can see as we do it, the meter deflects. And if we go up to the maximum scale there, the power supply is putting out, according to the meter on the power supply, which is not calibrated very well, the power supply is putting out not quite 5 volts, 4.5 or something like that. So from there, recalling that V equals IR, we could actually calculate the number of milliamps required to get the meter to full deflection here if we were looking to use it in a circuit somewhere. So there we tested that meter, and everything seems to be working fine with it. So with that in mind, we know that our test rig here is working. Let me take the wires off of the back of this meter in this thing, and we will see if we can get it to deflect as well. I don't think we need to take both of them off as long as I disconnect one so we don't have the voltage from the power supply going through whatever shit's down here on this little board. Probably wouldn't hurt anything, but I would like to be paranoid. I don't want to damage my tuner. If it can handle 300 watts CW, then surely it could handle like 5 volts out of this power supply. But, who the fuck knows. Now this meter is not marked for positive or negative, so we're just going to assume that the left-hand terminal, as we're looking up its ass, is the positive terminal. And if that's not the case, the meter will deflect backwards a little bit when we start to turn the power up, and then we'll know to stop and turn things around. So voltage is all the way down, current's up just a little bit. Oh my. Well, gentlemen, this meter seems to work. I'll be damned. Huh. So there's either something wrong somewhere else in this tuner, or I'm not actually getting power to the antenna jack of the 520. But if that were the case, if there wasn't a load on the antenna, the finals wouldn't have tuned up right. I don't think. I mean, obviously I've never tried to tune the finals in that thing without a dummy load attached to it. That would be stupid. You'd burn your tubes. I had to have output on that radio. So there must be something else wrong in this thing somewhere. Well, I am not a very fart smeller, but I think maybe it would be useful to check those diodes and resistor values. So there's nothing to go wrong with those inductors. So alright, so here's the schematic for that antenna tuner. You can see that the meter circuit down here, this is a separate board with the switches are mounted on and shit. There's not much on that board that could go wrong. There's just some variable resistors. I mean, it could be just way out of calibration, but here you can see that the reflected and forward power come into this whole meter circuit through these two diodes, and if either of those diodes were fucked up, we wouldn't get anything going to the meter circuit. So that's the first thing I'm going to look at. I think it's very unlikely that any of these inductors are bad. As I recall, yeah, those are those great big inductors wrapped around those roids, and if there was something wrong with them, we could see where the wires were burned. So I think they're fine. And all these capacitors are ceramic capacitors, and I don't think there's much chance that they could go bad, and none of the resistors look like they have gotten hot enough to die, although I would check them anyway. It looks like I can probably check all of those resistors in circuit and get an accurate reading. Nah, maybe not. I'll try it and see. I'm not going to desolder them just to check them. I mean, I guess we'll see. It'll go through. Yeah, those will look like they're in parallel through that one winding of that coil right there when I try to check them, so that won't give us a good reading. Anyway, yeah, so I'm aiming my sights at those diodes though. Yeah. So when I test these diodes, with the diode setting of this meter, I get about 300 millivolts reading. Ooh. I think my probes were just making a bad connection there. I get about 300 millivolt reading there, which is what you'd expect from a germanium diode, and I don't get any reverse reading on them. But when I put it into continuity test mode, I should get a beep. I mean, there will be some voltage drop, but I ought to see something. I ought to see something on these diodes. I would have thought about 700 ohms across them. Maybe, and it does this weird, funny business when I try to test them backwards, but that just could be because of the germanium leakage. I mean, germanium diode's going to leak a lot more than a silicon diode does, but I'm beginning to wonder if these diodes are bad, but I don't know what else it could be. This isn't, I mean, unless the 520's fucked up somehow. But it can't be, or I couldn't have tuned it. I couldn't have tuned the finals. The finals tuned up just fine on that thing. It gave me forward power of 100 watts when I had it hooked to a dummy load, according to the meter built into the radio. That can't be the problem, but I got nothing. I got nothing on this thing's meter. I'm very confused.